Welcome to the Deep Dive. We're here to unpack complex topics, get past the noise, and really figure out what's going on. Today, we're looking at something pretty fascinating, but also kind of confusing in space research. You've probably seen a headline, maybe it even made you pause. Spaceflight can speed up the aging of our cells. Sounds huge, right? Like, wow, this changes everything for planning trips to Mars or even just long stays up on the ISS. Now, we already know space is tough on the body. There's microgravity messing with bones and muscles, all that radiation. It's a lot. So hearing about something like faster cellular aging, that adds a whole new layer of concern. But here's the thing. The more you look into this specific finding, the murkier it gets. It starts to feel, well, contradictory, actually, especially when you compare it to, common sense or other things we've been told about space and health. So our mission today is to explore these discrepancies, see why this story leaves us with maybe more questions than answers.
Exactly. And just to be clear, we're not doubting the science itself. The experiments, the data collection, that's solid work. What we are looking at is the story being told based on that work. Does it actually hold together when you look at it from different angles? Is it consistent? Or does it show us where, frankly, we just don't know enough yet?
Yeah.
And sometimes, figuring out what we don't know is the most important takeaway.
Yeah.
That's perfectly fine in science.
Absolutely. Okay, so let's dive in. The main finding we're talking about. Human stem cells might age faster in space. And yeah, on the face of it, that sounds like a really big deal if that's true across the board. It really should make us rethink long-term missions, right? Sending people off for years if their cells are just, breaking down faster. But like you said, when you start looking critically, even just as an informed person paying attention, you start seeing these little inconsistencies, like cracks in the narrative. So let's unpack those cracks one by one.
Yeah, and that critical look is so important because headlines, they often simplify things way too much. They give you this bold statement, and you, the listener, have to step back and ask, okay, wait, does this really fit with everything else? Does it make sense? Let's do that now.
Okay, first big crack. This was about cells in isolation, not whole people. The sources say these experiments were done on human stem cells, kind of floating around in space conditions, not inside an astronaut. So how much can we really learn about what happens to a whole person from cells in a dish, basically? What are the limits there?
Well, that's a massive point, a huge one, because a person is so much more than just a pile of cells, even if there are cells genetically. In a living person, you've got hormones, you've got organs talking to each other, a complex immune system reacting to everything, even your mood, your psychological state can change your physiology. All of that interacts in ways we barely understand sometimes. So taking what happens to the cells alone in a lab or, a container in space and saying, okay, this is human aging in space, that's a really big leap. It's like that analogy, studying one single bolt to figure out how the whole car drives.
Right, the bolt matters, but it doesn't tell you about the engine performance or the steering.
Exactly. It's missing the bigger picture, the system dynamics. It highlights just how careful we need to be drawing broad conclusions from, well, quite specific data.
It really does. Okay, so that's the cells versus human issue. But then there's time. Crack number 2. The duration of these experiments. These cells were only up there for about a month, give or take. A month. That's not very long in space terms. Compare that to what we're actually talking about for future exploration, like Mars. That's 6 to 9 months just to get there, one way. Plus living there, potentially for years, under totally different conditions again. The timescale is just worlds apart.
Oh, completely. And that raises serious questions about, how applicable these findings really are. How can you take data from a 1-month exposure and then assume it tells you the full story about the effects of spending years in deep space? It really is like trying to understand a whole marriage after just 3 dates.
Huh. Yeah, good analogy. You get a snapshot, maybe, but not the long-term reality.
Precisely. You might get an impression, sure, but you're missing all the complexity, the ups and downs, the long-term effects. The inference feels stretched thin.
Very stretched. Okay, so short duration is another issue. Now let's get to what I think is the most confusing part. Crack number 3. The telomere tangle. Do they get longer or shorter? This one really throws me because we all heard about that famous NASA twin study, right?
Yeah.
Mark and Scott Kelly. Scott spent nearly a year in space while Mark stayed on Earth. And the big surprise was Scott's telomeres, those protective caps on our DNA, the things that shorten as we age normally, they actually got longer in space, which sounded almost like some weird anti-aging effect, super counterintuitive. But then this new research we're discussing today, it says the exact opposite for these stem cells. Their telomeres got shorter. just like they normally do with aging here on Earth.
And this is where it gets really, really puzzling
Hmm.
because telomere length is like one of our main biomarkers for cellular aging. It's generally pretty consistent. So to have one major study suggest they get longer in space.
Implying maybe you get younger, in a way.
Right. And then another study suggesting they get shorter.
Implying you get older, faster.
It's a direct contradiction. How can both be true? Space makes you older or space makes you younger? It feels like it can't be both. This really makes the whole conversation confusing, even for people in the field, I imagine. It suggests our fundamental understanding of how space even impacts ourselves at this basic level is, well, incomplete, maybe fundamentally flawed right now.
Yeah, it's like the data is pointing in two completely opposite directions. Which leads us to the fourth crack, this idea about reversible damage. It sounds maybe a bit too convenient. The new study suggests some of the observed damage might just reverse itself once the cells are back in a healthy environment like Earth. But thinking about it, does damage just reverse like that? When we age or get sick, things leave a mark. We don't just reset the clock by, say, going on holiday for a bit. Life doesn't usually work that way.
That's a very fair point. Biologically, stress leaves marks.
Yeah.
Illness leaves marks. Time definitely leaves marks. We call it cumulative damage. While our bodies do have repair mechanisms, sure, they're not perfect. Fundamental aging, damage at that level, it doesn't typically just vanish completely, cleanly. So the question becomes, why would space, arguably one of the most stressful, damaging environments we know, be uniquely forgiving?
Right. Why would that damage just potentially wipe itself clean?
Exactly.
Yeah.
Something about that claim feels a little too neat, like trying to wrap up a really complex, messy story with a nice, tidy bow instead of digging into the messy reality.
So when you put it all together, these inconsistencies really do pile up. Cells versus people, short trips versus long missions, telomeres getting shorter and longer, damage that maybe just disappears. It's a lot.
It's a lot to square away. And let me be clear again about the skepticism here. It's not saying the research is bad or fake. Not at all. The science, the experiments are likely sound. The skepticism is about jumping to big conclusions too fast before we reconcile these very real contradictions. It's like trying to build a house on, well, quicksand. You need a more solid foundation first. The human body is just incredibly complex. Space is incredibly complex and mysterious. Trying to capture all that with a simple space makes you old or space makes you young narrative. It just doesn't work yet. We're not there. And the real key for future research, for mission planning, isn't just more data points, it's understanding the context. Are we talking cells or people? Short trips or long ones? High radiation or shielded? These details matter immensely. We need integrated studies looking at multiple systems over longer times. That's the path forward.
So, thinking about all this, what should you, our listener, take away? For me, it's really a reminder that science, especially on these frontiers, doesn't always give neat answers. Sometimes it just gives us more questions. Sometimes the results clash, like with the telomeres. And often, the real picture is probably somewhere in that complicated middle ground, still waiting to be fully understood.
And that's where you come in. As someone engaging with this stuff, don't be afraid to notice the contradictions. Don't be afraid to ask, wait, does that really add up? You don't need to be a scientist to see when the story feels inconsistent.
Yeah, like the telomere thing. Longer, shorter. Clearly something's missing there.
Exactly. If the experts seem to be getting opposite results, it's okay for us to say, looks like we don't fully get this yet. And importantly, that's not a failure of science. That is science happening. That's discovery in progress. It just shows there's so much more to learn. And being honest about that uncertainty, that's far better than pretending we have it all figured out when we obviously don't.
So where does that leave me? Honestly, feeling pretty much like the source described. Fascinated, definitely skeptical in the way you outlined. And yeah, a little bit amused too. Yeah, we've got these grand dreams, right? Going to Mars, exploring the cosmos. And yet we're still grappling with this really fundamental question. Does space make us older or younger at a cellular level? The answers seem to be all over the place right now.
And maybe that's part of the point. Maybe space exploration's greatest gift right now is forcing us to see the edges of what we know.
Wow.
It pushes us to question harder, to design better experiments, to rethink our assumptions. So the next time you see one of those big headlines about space and health, approach it with curiosity, absolutely, but also with that critical caution. Ask yourself those questions. What's the real context? How long was the study? Does this fit with other pieces of the puzzle?
Because if life teaches you anything, it's that the truth is hardly ever as simple as a headline makes it sound. And when the story keeps changing, when the evidence pulls different ways, maybe the smartest thing is just to admit, okay, we don't know yet, and keep asking questions. Thanks for diving deep with us today. We'll catch you next time.